Hi, I'm Emily Moyer, and this is Lab 1, Constant Velocity, for Physics 1, Section N01. The purpose of this lab is to view an object moving at the same speed without changing direction and applying Newton's second law to explain what occurs in the video recorded. This was done by taking a video and using Tracker to obtain the object's position and time. I recorded this video so that it went from left to right to show a positive constant slope, which makes more sense when doing calculations and results in positive data rather than negative. The clip was cut down to 30 frames from a range of the 50th to the 80th out of a total of 120 frames to avoid both the starting point of the subject pushing off of the ground to get the rolling chair in motion and also the point at which the chair slows down due to an outside force, since that's not what we're testing. The frame rate of this video was also altered because it was a 3-second long video and there were a total of 120 frames. In order to account for this, the frame rate was changed to 40 frames per second in order to produce accurate position results relative to the time. The subject being measured on Tracker was the length of the subject's head as she rolled across the Kolk on a rolly chair. The distance of her head from the tip of her nose to the back of her head with her hair down was measured to be 22 centimeters, which was converted to 0.22 meters. This was used for the calibration stick as a source of relative measurement. I also made sure to slightly tilt the axis of measurement because the subject does not move perfectly horizontal on the film. The point of this lab is to observe the object at the point of zero net force, which explains the nearly linear graph results. The initial velocity is 0 at placement 0, as seen on the graph. For all the models with graphs of time versus position that show a straight line because there is no outside force, the result is a constant velocity. The constant velocity was found from the initial point of velocity and placement both at 0 and the point directly after this first point. This second point was found to be at 0.025 seconds and 0.0312 on the x position axis. To find this initial velocity, a simplified version of Newton's law, which is the equation v equals delta x over delta t, was used with these two first points and was found to be 1.25 meters per second. As a comparison, this velocity was used as a constant velocity to predict an object with similar weight and no force in a computer program called VPython. This program was altered by making this velocity the constant velocity, as seen here, and also ensuring that the rest of the program was a similar model of the actual experiment. This also includes making time, which is part of the loop, less than 0.751 seconds, so it will continue until the last second as recorded in the clip that was being used. After running this program and finding the data points, the observed and predicted positions versus time were plotted. It was found that there is a noticeable difference in the predicted and experimental data points as seen on the graph. However, the velocity varies throughout the experimental data, depending on what points are used to calculate the velocity, which explains the variation between the model and the experimental data as seen on the graph. For example, if the velocity was taken at a point such as here, then there would be a much steeper slope of model position as determined by VPython than compared to what we got from using the first two experimental points. In general, this experimental display of an object with constant velocity worked well. The model was better because of various extenuating circumstances. The rolling chair was rolled on a flat concrete surface, however the wheels were still inevitably going to slow down. Also, the wheels of the rolling chair were not going to go in an exactly straight line, which could have caused a slight increase of velocity during the experimental data as the subject rolled closer and/or farther away. Also, my filming abilities were not perfect. Although I made sure to upload the video directly to avoid compression of the file, I found it difficult to keep the film still while it was recording, which could definitely affect the velocity that the Tracker program perceives. Either way, this experiment accurately portrays a realistic application of the momentum principle. Thank you.